Hey everybody, good evening. As much as I would like to finish listening to Stevie Ray Vaughan, this is your time, so I can listen to that on my time. Everybody's doing good this evening. Had a good weekend. Welcome to class 11, where we're going to be talking about AI for network security. Um, Usual preliminaries with regard to the syllabus. We're week 11 already, if you can believe it. Uh, we're going to build on the topics from class 4, 5, 7, 9, and 10, and hopefully bring some of that stuff together. We've got some interesting stuff coming up on NLP and adversarial AI, and we'll be talking a little bit about ethics. And, network security is a key part of what we do. Some people would argue maybe it's the only part of what we do, but I don't know how I feel about that as a former network engineer. But anomaly detection and UBA is all kind of network based. So think about how to weave those things into what we're talking. Uh, Assignment structure. We're coming up on class 12, where we'll be doing final model and validation. Then we're going to have a little bit of a lull with no assignment up till the capstone project is due. Uh, so we'll talk a little bit about that. I'll get some requirements out here this week as to what we're going to want to see in that. But basically, it's going to be you've done all the work. Tell me about it, I think is kind of the gist of where I'm going. So how do you present a result from the data we've analyzed? And that will hopefully be something that will be more clear to you now that we've covered the majority of the material. And again, this has been the fire hose turning on part. We're gonna kind of I won't say dumb it down, but the intensity hopefully will go down, but I can't guarantee that. Maybe that's wishful thinking on my part. So the agenda for tonight, we're going to talk about network traffic analysis, anomaly detection, DDoS attack mitigation. I've got a cool notebook I put together with some quote unquote real attack data from one of the data sites that we've been talking about. How does that fit into firewall optimization? We'll talk about that a little bit more. This is becoming a hot topic. How do you optimize controls using artificial intelligence, aka machine learning, right? There's no artificial intelligence. It still requires a human in the loop to interpret this stuff and program and run algorithms and do that, which you can now do. So how do you use that? Did a case study with a notebook. If you haven't got the notebook yet, go up to my GitHub if you want to follow along. If not, I'll be showing it live as we go through the presentation. Got some feedback that there was a desire for a little bit more hands-on, so I'm going to try and do a notebook for each one of these lessons that you can follow along in, and then we'll just kind of see how that goes. Okay, so as you know, anybody who's in InfoSec knows you're constantly under attack. You're being scanned 24/7, 365. People are password spraying. They're doing all kinds of cool stuff. And the reason they do that, it's like, why do people send spam? It's because people respond to spam. Why do people scan and do password spraying? Because they get results, right? And essentially we put the entire internet under assault by people trying to find defects in our controls, and that's just kind of where we're at. So you know as a former network engineer and having been a responder, I can tell you that you can't do this stuff manually. The kind of tried and true quote unquote approaches do not work. You can't do signature based anything and get results that are worth beans, right? um, it's just we're past that. We're over it. And a lot of the stuff that we talk about doing in this course with respect to data analysis and cleaning and machine learning and all that stuff, that is the force multiplier. Because how could you go through all the cells in a spreadsheet and do the stuff that we're doing? Could you do it? Yes, but it's not scalable. So what we're trying to do is automate this. and scale it in a way that it's useful to us real time. And we don't have to go through and figure this out every time, right? I've been a tier 3 responder in the bad old days when you're hunting manually and you don't have like tools at your disposal and stuff like that. And you might find one needle in a haystack, but there's probably lots of other needles that you never had a clue. So this is super cool that we're at this point where we're finally have a way to make this accessible to the average practitioner, of which I am one. I'm not a data scientist, I'm not a developer, and I don't need to be because I have an LLM. So the goals are right that you should be able to analyze traffic, look for anomalies. What's AI's role in making current technologies that we have better, right? And then, how do we use this for things like network segmentation and things like that? So we'll talk about traffic analysis, DDoS mitigation. That's a fun one. Firewall optimization. I've got a case study that we'll go through and a Jupyter notebook that accompanies that. Unfortunately, guest speaker has issues. They were called into an incident, so they're not going to be able to join us. My apologies. I'm going to try and get both of them rescheduled before the end of the course here in the next few weeks. And because I know that's important, you probably want to ask some people that work in the field besides me questions. So we'll get those rescheduled again. My apologies. Okay. So if you remember what we talked about before about IDS, my favorite technology to hate, right, is, essentially it's a noise generator. And we also talked a little bit about signature-based versus behavioral AI, quote unquote, enhanced, right? We're using machine learning and we're automating it with AI. And what we want to do is, right, we can't know everything that's bad. And what we want to do is we want to move to a point where things are unknown normal, right? So we don't know they're bad, but they're different and we need to take a look at them, right? So do you want to spend your time going through and documenting false positives and writing reports that say why it's a false positive? Or do you want to spend your time investigating anomalies and figuring out why they're different, right? I think the latter is a much more useful consumption of our time. So that's what I'm advocating we're moving to. Not that we get rid of people because we have AI and we don't need people to tell us, what the false positives are, but we're going to enable people to do work that is actually useful by using tools at their disposal. That's why you want to be an AI wrangler. That's why you want to take the concepts that we're teaching in this course and apply them to things besides, machine learning for cybersecurity. You can get a lot of stuff done with an LLM. So, use it to your advantage. And then today we're going to kind of go deeper into the network infrastructure. And I'm sure all of you can think of examples of anomalies that you've seen in networking, right? It's like, oh, it's an interesting data flow, or maybe there's some addresses that we don't understand, or some strange behavior from an account, right? There's all this stuff that has network indicators that you can use to figure out exactly what the heck is going on. All right. So imagine you had to monitor every conversation in a city and try and figure out if somebody was planning a crime or an act of terror, or there was actually something subversive going on. You couldn't really do it, right? Because it's just a babble of voices. And unless you want to monitor all the conversations, you need a person at a time to do it, right? And conversely, think about all of the data that flows in from all the different telemetry sources in an enterprise, right? You could have, gigabytes, you could have terabytes of data, you could have petabytes of data, right? Depending on the size of the enterprise, right? Hey, I worked for Google. You should see how much logs they have at Google, right? So, it's a scale problem, and our adversaries understand that. Some of the examples we've provided, especially the malware data set, right, is artificially dense, right? Anomalies are rare, anomalies are sparse, right? They're something out of the ordinary. And you figure the average data set has maybe 1% anomalies, so it's a little bit harder to figure out what things are going on, right? So this is back to the shape that I always talk about. I always go like this, right? The shape of your network. So what we're talking about is it's almost like if your network has a personality, that is what we want to learn, right? We want to understand what the baseline personality is. So think about some of the techniques we've used, things like one class SVM. Here's what's good and here's what's not good, or here's what's inbounds as far as being normal, and here's what is anomalous. We only want to look at the anomalous. So we're improving our ability to find these patterns of anomalous behavior that might indicate a compromise, right? We also talked about this before. These concepts transcend different approaches, right? The temporal patterns, right? What is going on in normal business hours? What's going on not in normal business hours? If you work in financial services, I bet you have to take a vacation and you can't log into the network. It's because your fraud and security team wants to see if there's anything going on with your account while you're off the network. So there's a bunch of different things, right? Seasonal variations. If you're in retail, you're going to have a lot more traffic holidays than not. How do you account for that? This is back to when we talked about unsupervised learning, and don't set the expectation that you're going to get results right away, right? You need to go through a business cycle and you need to tune at each inflection point to make sure that you are accommodating the seasonal variations potentially in your network traffic, right? People go on vacation in the summer, there's less traffic. Everybody works from September to the end of November, and then they go away for Christmas and the New Year. So think about those kinds of things. Of course, in case you're in retail, but you know that. So so lots of different things. Uh, you know, can you fingerprint a protocol? How does it normally get used in your environment? This is interesting. We were doing this at Amazon. We were looking at the traffic patterns of APIs. And when we found anomalous patterns, we were trying to figure out why was that, right? You can usually classify things normal, abnormal, and if you understand what normal is and you have suddenly something that's different, is it bad? I don't know, but I should probably go take a look at it. Real-time monitoring. I can't remember. I mean, it's like months versus hours is the difference in mean time to detect, mean time to respond if you're using AI techniques versus standard techniques where you're using standard detections, right, as opposed to looking for anomalies. So think about that, right? You've got people that are wading through the sludge, and maybe they have to get hit in the head with a hammer a few times before they realize what's going on, and that's kind of what you're dealing with if you're using atomic detections, right? That we're saying what's bad, and we're not looking at what the data tells us. And human analysts, if you are a human analyst, you probably know this pain better than anybody, where you're just inundated with data that you have to pick through and you have to make decisions about. And it's not fun, right? I mean, and think about this. If you're a person who has to do that and you're classifying information as legit or a false positive, you have a training set, right? You have labeled data that you could use to train an AI model. So go do that. Um, you know, if you look at anomalies, right? If you look at normal versus suspicious traffic spikes, oops, sorry, I advanced the slide. I didn't mean to, right? You can see that, and this is a view that I did for a DDoS attack. You can see the differences in traffic volume, right? And this is like the highest variance feature. You can see that it's pretty clear what's difference between normal and anomalies. It's easily detectable. And you can see these anomaly detection results as well. So it's when you process the data and you use the techniques that we've been talking about, you can tease out and you can say for sure, right? If you say I think, that's a different conversation than if you show up with data. All right. So we can talk about volume anomalies, right? Which is like a traffic spike you might see in a DDoS. You might see protocol anomalies. There's things like DNS tunneling. Behavioral anomalies. I have an account that's suddenly logging into a bunch of different servers, even though it can't get in. It's never done that before. So these are the kinds of things that we're looking for. We're looking for the things that are out of the ordinary. So if you look at this is a breakdown of a DDoS data set that I downloaded and I built a notebook around, right? You can see that it breaks out what's DDoS and benign. In a DDoS, as opposed to what we've been talking about before, where you have a very small percentage of anomalous traffic, a DDoS is a flood, right? So you're going to have a large percentage of anomalous traffic. So you have to think about that as you're analyzing it. Sorry, some mouse gestures advancing the slide. A feature correlation heat map. This is interesting. How do I figure out what is it DDoS or not, right? If I look at these features that are correlated at 1, right, I know that Forward IIT and Flow IIT together, that those are good things to look at, right? If you do your principal component analysis, it's going to be a composition of all these highly correlated features and their relationship together. And what we're doing with like principal component analysis is we're doing dimensionality reduction, right? That's less features, but we have features that we engineer, which are these principal components, or actually algorithm engineers them for us, which is even better. But basically, we are combining multiple features to have one indicator that will help us determine if we have an issue, right? The features by variance, we've talked about this a bunch. The more variance there is in a feature, the more interesting it is, right? Because we want to try and figure out why that variance exists. And then, things like destination port distribution. If you look at normal traffic, it goes to certain ports, right? But if you look at the anomaly traffic, a lot of anomaly traffic goes to low ports, right? So you've got port on the bottom and volume on the side, and you can kind of see that distribution, right? The reason I know, even though there's no label, which is bad, is because we have 65535 ports, and that's kind of what that bottom shows us. All right. So let's talk a little bit about how artificial intelligence for DDoS attack mitigation, right? A DDoS is a flood. What someone's trying to do is they're trying to deny us the ability to either use our network or serve our customers by putting so much traffic on the network that we are impacted, impaired, we can't service requests. We've consumed the resources on our front end servers, that kind of thing. I was at Microsoft, and at the time, we had the largest DDoS ever recorded pointed at Azure. And we said, haha, we had enough bandwidth that it didn't matter. We just provisioned some more circuits and things were okay, right? But if it was a different type of DDoS attack, maybe there would have been issues. But that's a pretty common approach to DDoS these days, is people have so much bandwidth that it's just impossible to consume it all. So maybe they're trying to do resource exhaustion on servers by having a bunch of connections and things like that. But that would be where you could address it through tuning parameters on your front end and kicking off certain types of connections and that kind of stuff. So There DDoS has always happened. They're always in the news. You should go look up current DDoS attacks and see what's out there, what the types are. But it's a nuisance and it's a pain in the butt. If you ever want to have fun, have your customer get DDoSed on Christmas and try and get a hold of somebody at the carrier to put a BGP block in so that the DDoS doesn't get routed to your network. Takes a long time. So not cool. All right. So what are some of the tactics that we use and techniques that in AI that can help DDoS? Traffic profile, right? If you have a statistical baseline of normal traffic types and you start suddenly getting anomalous traffic and connections, you can identify those early and you can automate inside your network to put blocks in place or filters to kind of tamp some of that stuff down. Um, you know, geographic patterns, if suddenly you get flooded with traffic from a certain region, we see this frequently, where people target things in certain regions. You can address that through configuring your network. Again, you understand what's going on. User behavior, if you suddenly have users doing anomalous behavior. I had a customer where their busy season was in the holidays, and I was having a conversation with one of their leaders, and it's like, oh, hey, all of a sudden we got all these accounts that showed up in our system in just the last couple of weeks, and we started looking at them, and they were coming from interesting geographies. I think most of them came from China, and they were like nonsense names and things like that. And I was like, oh, you're about to get DDoSed on Christmas when your new product comes out. And he was like, oh, how do we prevent that? And I said, well, take all those accounts and make them do a password reset and see what happens, right? Because obviously it's automated. So we did that and we subverted an attack. You just got to know what you're looking for. Um, you know, Internet of Things, botnets, right? This is a new frontier operational technology. Uh, there's a lot of dark corners in the Internet of Things. I've personally seen attacks where unpatched Internet of Things devices were used as a command and control foothold, right? It was a persistence mechanism that they used to set up a VPN that they could log back into. It was an unpatched IP phone. So it's a real issue. If you look at what do we use our IoT technology for? Environmental in data centers and power management for generators and things like that. All that stuff runs on IoT. Security systems run on IoT. Do you think that adversaries aren't targeting that? That you bet they are. I think when IoT devices first came out, the thought was, well, hey, we're just going to put this in. It's going to be there for 20 years and we're never going to have to do anything to it. We're not going to have to patch it. And there's problems. I've seen platform issues with servers that support cloud infrastructure where they had IoT vulnerabilities in them and stacks that required a lot of hardware to be replaced because it was unpatchable. So, the littlest thing can cause you big problems, and our adversaries are out there looking for those types of things. Real-time detection, right? Uh, we want to know now when something's happening. We don't want to know when somebody finally gets to pick through the false positives to say something's a true positive, or that you get signal after signal after signal, and finally it's blaring right in your face, and you need to take care of it. And that's how things linger for days, weeks, months before you find them, right? Uh, you need to adapt the thresholds for your detections so that as conditions change, like we talked about, time of day, temporal things, business cycles, that you can adjust your detections. So, there's a lot of this that goes into it. So, I've given you a couple of case studies, right? The things that happen during holidays, things that happened through Internet of Things, stuff like that. And what really, how do you distinguish between a legitimate shopper and attack traffic, right? Legitimate shoppers all act kind of the same. Attackers don't, right? Attackers, um, it's a volume game with them, right? So you might see an uptick in a certain type of volume that would indicate a potential attack, right? So if you don't have a baseline, if you're not looking at the numbers using some of the techniques we're talking about, it might be a little bit harder, right? Um, all right. And then if you look at these plots, right, we used k-means here to identify some attack patterns, and you can see that it gets clearly called out, like in this second graph, the distance to the cluster center, where an anomaly, the distance is a lot greater, right? Because that is definition of anomaly. If you think back to some of the graphs we've shown where there's a cluster center and then you have the shape that surrounds the cluster and you get to a certain point and you're outside of it, that's what we're talking about here. And these are some of the things that we're taking a look at. So, and then how do you use this technology, right? Other than it sending you an alert or you finding something through analysis. Today we have things like AI aware firewalls. Michael, your question about where I'm getting the data sets, I will share that. I have a whole list of them in my GitHub, and I actually have a list that's called data sources that I'll share with you. Okay, so firewalls. This is a good one. I've seen this actually implemented, and firewalls. The rules are crap, right? You get a bunch of them from the firewall vendor, and how many times you heard we need to turn all the rules on? We need to have more rules means more security, and that's not true, right? Um, I'm so old that there weren't any firewalls when I first started doing networking security, right? We were putting access lists and routers, and that was our firewall. Today, firewall can have 10,000 rules. Who knows everything about 10,000 rules? I had a client one time who was also a network engineer, and he felt like he could go through and he could tune his own firewall and he knew what the parameters should be. And as soon as we turned the firewall on, it crashed because it didn't have the processing power to process all the rules, right? So, some firewalls say, well, hey, if I can't process the rules, I'm just going to let the traffic through or I'm going to discard it, right? Everybody says, oh, we'll just let the traffic through. And that's how adversaries get themselves inside the wire, so to speak. You can have the limitations, right? Is you got people that are administering this. Do you know all the conflicts? Do you know what rule trumps the other rule? What the hierarchy is? Are there unused rules? People that spend a lot of time sitting around looking at their firewalls. And then, the performance thing is like I was telling you about the order dependent processing. Uh, that takes a lot of power just to process the rules. And then if you lay a lot of traffic on top of it, you could have potential issues, right? So how can AI enhance this, right? Uh, it can make policy recommendations, right? By discovering applications and mapping, right? So we're just going to do rules for things that are actually going through our firewalls, and we're going to call out things that are new and unusual that we don't normally see. We can prioritize rules by risk, right? What is the relative importance of this rule versus another one? Should we run one rule before another? These are all questions we can answer using machine learning and AI techniques, right? Um, here's one. Who likes writing documentation? I do not like writing documentation. That is my Achilles heel. Documentation, presentations, code, right? I'm happy when I'm just sitting there tinkering away in my data saying, oh, hey, we should look at this thing, right? But you gotta document things, you gotta do presentations. AI is a big help there. Hopefully you've gotten a taste of that as we've been going through this course. Um, right? We can detect redundancy, right? What are examples of rules that overlap? We can use AI to resolve conflicts between priorities and different rules. And then we can also use it to optimize performance. So, you could probably take a rule set and tell a LLM the model of your firewall and say, here's the rule set, and it could optimize it for you. I haven't tried it. Might be an interesting thing that I'll go and do, but it's a lot better than trying to figure it out yourself. It's like I got a spreadsheet and I got the documentation, and I've done this before, and it's terrible. It's like, what does this rule do? What does it mean? Why is this more important than another? And pretty soon your eyes crossed and you're just like click, click, click going through it's a real problem. Um, can you do things like, can you have a threat aware policy, right? How do you integrate IOC detection with a firewall, right? What could do that correlation for you, right? You can use AI techniques to do it, right? You could write some Python code and have that happen for you. Things like reputation-based blocking and behavioral analysis integration. These are all AI features that you're finding in firewalls these days, right? Your firewall can be hooked into MITRE ATT&CK, and it can tell you, hey, I think this adversary is staging an attack on you based on the traffic, right? By doing that kind of correlation. It's pretty darn cool. Whereas before, it's like, oh, I get the information and I have to go try and look at MITRE ATT&CK and figure that out. I've done that before. It's a beating. So this is super helpful to have this available at our disposal. Same thing with performance tuning, right? It's like, oh, I move the slider and I analyze the network trace with Wireshark, and I'm looking at the network throughput versus processor utilization and things like that. Forget it, right? We can do that now using some of the features that are built into advanced firewalls that are driven by AI, right? And you can do some of that same analysis yourself. And then that helps also with the resource allocation optimization, right? So, if you look at this screenshot of a firewall, right, it has an example of some of the AI rules. I forget where I got this. I had it linked in the slides when I built them, and it looks like the link got lost. But anyways, this is an AI enabled firewall is the actual product, and it it shows you some of the advantages that we have today with respect to firewall analysis, and also some of the outputs that it can show you as the firewall's running. A lot of them today have LLM chatbots, right? You can ask them about a rule, you can ask them about information, you can say, get me everything about this particular log entry, or tell me what's going on with the source or destination, and they collect that information and bring it back for you. So much like we're using LLMs to help us fetch Jupyter code and explain it and help us with machine learning, those same features are available in firewalls. And then they can also update policies automatically, right? This is the next big thing. We implemented some of this at Google. We had an issue with compromises that were occurring in one of our environments. Once we figured out the root cause for it, we were able to detect that and take automatic action, where we would take a GCP environment off of the internet and put it into a timeout, basically, where that we didn't shut it down, but it couldn't access the internet, and the internet couldn't access it because we were getting killed with coin mining. So we were able to do that, and we could isolate it, and we got notified about it, so we could take immediate action and figure out if it was actually an issue or if we were impacting a customer or internal user. And that was all driven through AI, but it was figured out with machine learning before we automated it. All right. So let's talk a little bit about the case study, and got some feedback, which was good, about we wanted some more hands-on case studies, right? And So I created this notebook. You can follow along with you. This uses synthetic data. And basically, this is an implementation of uh, how you would potentially do network segmentation using artificial intelligence, right? So there's a couple different things, right? When you talk about AI enhanced segmentation, basically today we have it's a difference between putting up a fence and living in a castle, right? A castle has multiple defenses versus a single perimeter. And traditionally, firewalls have have been just like that fence. And a lot of times it's manual, based on things that we know about. It's not based on behavior. It's based on other factors, things like VLANs and atomic detections. That are built where we know it's bad, and everything that is bad we're going to catch because we have all the detections. And we know that just doesn't work. So today we have remote work, bring your own device, cloud workloads. So things are really changed. um there's application dependencies. We need to understand those. We can use machine learning to cluster communication patterns. um Zero trust principles, this is super important. I've talked about this a couple of times. The graph approach to access, right? Who has access and how do they have it? A lot easier to figure out with machine learning than just trying to look at the group ACLs and try and figure it out in Active Directory or wherever. um you know, with AI, you could do micro segmentation, right? You could uh, segment down to a container, right? You could isolate containers. You could have policies that are specific for workloads, so it's not a one size fits all kind of policies. Uh, you can look at traffic, source and destination. Some people call it east-west traffic. Uh, see what's going on, and you can direct certain traffic to certain segments so it doesn't go everywhere all at once. Um, you can automate policies, right? What's the intent? Uh, is it a connection? Is it a query? Is it scanning? Uh, what gets through, what doesn't? Uh, I talked about this with the Google and example, right? Self-healing network configurations. uh, you can automate that. You could set up a detection using machine learning, and then through scripting driven by AI triggers based on the machine learning, you can take actions. Uh, Compliance automation. Everybody's probably heard of Terraform. Terraform's great. Hey, if my container doesn't match the template that I set forth for it, I want you to burn it down and regenerate it, right? Super useful if you're ever deploying an application, right? Is you say, if this doesn't match what I deployed, get rid of it. It's one of the better features in my humble opinion, right? Uh, we have talked about this a little bit in the past. Anomaly-based isolation, right? You can detect lateral movement. Hey, this account is logging into a bunch of servers, and oh my gosh, it was denied 20 times, but it got in one time. So let's go look at what's going on the server I got into. Uh, Automated quarantine. I gave an example of that earlier, and that tied in with kind of recovery workflow. Coin mining. Everybody hates coin mining. Coin mining is a big problem for cloud providers. Causes things like stockouts in regions, right? So I have a certain amount of excess capacity that gets consumed. So if one of my customers needs additional resources, they can't get it because somebody's WordPress site got jacked and there's a coin miner running on it and it's using up all my resources. And then I'm not going to make mom and pop bookstore who had an insecure WordPress implementation pay a $2 million cloud bill at the end of the month because they got nailed for coin mining. True story. I mean, millions and millions, if not billions of dollars get wasted by cloud providers because of things like that, right? Because you're not gonna penalize an actual customer, not necessarily. Uh, so I've seen this a bunch. I've seen it in research. I've seen it in demonstration environments. I've seen it in production environments. It's a big problem with cloud providers because they all give you a free trial and people get those free trials and start coin mining. So there's machine learning detection that finds that and shuts it down. But it still in the interim, what's the time between it happening and it gets shut down? And what does that impact that, right? So AI helps with detection, isolation, investigation, and really implements or really helps the speed. Okay. So all right. So benefits AI network security, right? Again, it's speed, it's accuracy, scale, all these things we talk about, that help solve the swivel chair problem, which if you're a tier 1, tier 2 analyst, you know exactly what the swivel chair problem is. I have an endless torrent of things that I need to pick through and I get tired of looking at them, right? So it's called alert fatigue. Uh, Adaptability, right? It's always learning and evolving. It isn't strictly pattern based or based on the knowledge of a particular analyst. It's the culmination of all and integration of all that knowledge together. Cost effective, right? How much quicker is it for machine learning algorithm to go through and look at something and give you results as opposed to humans doing it? Big difference. And the ROI is certainly there. So what are some of the challenges, right? Got to be honest about this. It isn't a panacea. Remember back to class 1 when I asked, is it a panacea or is it Pandora's box? It can be both, right? Some people think it's a panacea. A lot of people don't understand what it is or how to take advantage of it. Uh, but there are definitely limitations. You got to be knowledgeable about it, or you got to be acknowledge those, right? Um, you've got data requirements, right? What data do you have access to? A lot of times it's hard to get access to data. You have to pry those doors open. Why do you need to see that data? So you have to work through that. You have to store it, you have to process it, you have to worry about privacy, right? If you're collecting command lines, for instance, right, there could be personal data in those, even if it's your internal users. Can you explain it, right? Um, it if you have an auditor come in and you have a fancy machine learning control in place, can you explain that to them in a way that they'll buy it? Can you explain it to your leadership? You say AI and they're like, oh my God, we don't want to use AI because all our corporate secrets are going to go out on the internet. Well, no, that's not exactly what we're talking about, right? We're talking about statistics on steroids. That's a term I like to use, right? Don't say AI, say machine learning, right? We're looking for statistical anomalies. They'll understand that. Um, Adversarial concerns, AI versus AI. How do you think that AI could be used to figure out what the margin is for a detection, right? We have adversarial AI we're going to talk about later. We're going to examine some techniques, but it's pretty fascinating, right? You can do it pretty quickly if you know the proper techniques. Um, it's complex to integrate, right? You have legacy systems. How do you integrate it with that, right? You have to think through those things. Resource requirements. Not everybody is going to be an AI wrangler, right? Some people might be protective of their turf, right? You have a lot of developers and machine learning people that that you don't really need anymore, right? You don't need a developer to write Python for you anymore because you can do it with LLM, right? You don't need a data scientist to figure out what all the parameters are for one class SVM. You have an AI, you can use that, and you know how to do that. So you might have problems breaking through that, right? So you just got to work. And it's a balancing act, right? What's the benefits versus the challenges? Be prepared to have the discussion and have an idea of kind of what the return on investment is. All right. So let's talk a little bit about the case study. And this is a companion that I put together, and this is based on the network segmentation case study. And implement some of the concepts. Again, this is based on synthetic data. This is up on GitHub. You can follow along with this if you want, or you can run it later. It doesn't require any external data. It makes its own. Of course, all the graphs look fantastic. Everything is perfect because it's a simulation, but hopefully this gives you some ideas. But you can also see that we're following the same process, the machine learning lifecycle that we talk about in this example as well, right? So the first thing we're doing is defining the problem and setting it up, right? We've got all our imports. Let me make this bigger so you can see it. And we run this first cell, we import the libraries. It gives us the objective. And the next thing we're going to do is generate synthetic data. Unless you're a super nerd, you probably don't care so much about this. But basically, what this did is it generated 10,000 network flows, and it gave us some basic information. Where have you seen this before? What's the shape of the data set, right? It put 500 anomalous flows in there, right? Tells us what those anomalies are. And then we're going to do some exploratory data analysis. Okay, so this is it. Trying to get fancy here with Jupyter Notebook. So so sorry, too fancy for myself. So basically what we did is this code did this basic analysis for us, and it gave us this output view. So sorry. It shows us the network flows. It shows the anomaly injections, right? This is the raw data that got generated. It shows us the traffic distribution, the bytes sent, the CPU usage, gives us some information about the communication between departments, protocol distribution, a nice scatter plot showing the normal versus anomalous traffic, the ports contacted, uh, gives us the feature correlations, and sort of this is the base of the data set, right? So we've got 10,000 flows, and we've got a handful that are anomalous, and it shows us kind of what those rates are. All right. So the next thing that we're doing here is we're preparing our data. So we do some basic things. We engineered some features, right? So what we're doing is we're combining some of those existing features and we're creating a new feature, right? This is something you can do anytime. Sometimes, like if we do principal component analysis, this will get done for us. And then we're doing some rate-based features, some behavioral indicators, and then calculating a risk score. And again, this is all synthetic data. This doesn't really necessarily mean anything, but it is based kind of on real techniques. And then we enhance our flows with the features, right? So what are we doing is we're adding some extra columns that have these additional features in them. And then we're going to prepare the data for machine learning, right? Of course, we know exactly which columns we want to do analysis on because it's a synthetic data set. We're doing encoding, adding encoded features to the list, and prepare the matrix, and then we're done pre-processing the data, right? We've scaled it, we've encoded the labels, we've engineered some additional features. So this is all stuff that you've done already, and now we have a result, right? So how many new features did we add? 9. Here's the new features. Completed the data pre-processing. Now we have the feature matrix shape, right? Instead of 11 features, now we have 20. And then we have our target distribution of, how many, because remember, this is a labeled data set, labeled 0 or 1, and this tells us what the distribution looks like. Okay, so now what we're going to do is we're going to develop the model. So we do some grouping by clustering, some based on communication patterns, and we get some results. We have a plot we're going to look at here in a second. Here are the different algorithms that we used. We did k-means and dbScan for clustering. We built some anomaly detection models, right? Very important, right? Got to split the data. So here we go. We're doing isolation forest, unsupervised, random forest classifier, supervised, right? These are all algorithms that we've used before. We do the evaluation. How do we do that? If we're doing supervised, it's easy, right? We look at our test data, we run it through without the label, and then the unsupervised, we just run the data and we check it against the label, and we return these things, right? And what this does is this gives us some clustering results. So this code that we just looked at here generates these graphs. And this is what we want to, this is actually the important stuff that we want to look at. So here's the k-means clustering results. And you can see that it gives us a pretty clear indication of what is normal and what is anomalous, right? We can see the anomalous stuff up here in a separate cluster. And we have all of our scoring of our algorithms, right? We have our isolation forest, we have random forest, and we have our confusion matrix. And this tells us by attack type how accurate we were in detecting it. So, of course, because it is synthetic data, the accuracy, precision, recall, all that other stuff is super good. Yay. It's not going to be like this if you do this yourself. If we look at like the DDoS example, so this is a real DDoS log file that we went through and did the analysis, right? So this is labeled, right? It is 250,000 samples with 79 features. This takes forever to run, and I've got it set in a fast mode, but it's super cool, right? So this is a similar kind of thing, but this is real data, right? There's DDoS traffic, there's benign. We have our feature correlation matrix. You can see from here, right, what the principal components might be, right? They have a high correlation. You'd have to understand the variance, right? Which is this next graph. What's the top 20 features by variance? Excuse the garbage here at the top. I was trying to put a label on these and I didn't have time to fix it. Or maybe I didn't have the will to fix it, but basically this shows you graphically kind of what the top 20 features are by variance. Shows you normal versus anomaly traffic, shows you what the normal mean is versus the anomaly mean. Remember, if things are negative below the mean, then that means that they're anomalous. But you can see that there are clear differences between normal traffic and anomalous traffic, right? We took the label column out, so we have 78 total features, and then we have a bunch of information about it. We have our k-means anomaly detection. We can see what is normal, what's anomalous. We saw this earlier, right? The distance to the cluster center distribution. You can see clearly what's normal, what's anomalous. Cluster size, the same kind of thing. Anomalous clusters versus normal clusters. And then the anomaly scores, this is the biggest one here, right? Is you can see that things that are below 1 are anomalous, and it's pretty clear based on that. I mean, this tells you the cluster ID and the distance to the center, but you can see how the anomalous clusters are below the other one. And then you can also see here we did some cluster optimization. You've seen this before, the elbow method. We know that there's 2 clusters, there's normal and anomalous, but you can also see here the elbow method picked 2 clusters, and so did the silhouette analysis. So that checks out, right? Your domain knowledge says there's 2, and guess what? This got proved out. And again, this is actual data. This isn't the synthetic data. So this is just an example of how these techniques work. Same thing here. We ran all the algorithms. This is the thing that takes forever. And then you have this result, which I'm going to show you in a separate browser. But this gives you the confusion matrix for all these different calculations. And it also shows you the area under the curve and which algorithm would be best for detecting DDoS. I am not surprised that one class SVM is it, because DDoS is pretty simple. It's either on or it's off. But you could see here from the confusion matrix that we would probably want to tune our one class SVM a little bit better, because we have a high number of false positives, right? You can see that here, got 25,000, right? But the biggest thing I'd be concerned about are these false negatives. The reason for this, what do you think this is? What in one class SVM, what's the parameters? It's new, NU, right? It's probably set to 0.2. And if you remember our distribution of how many DDoS samples we had, it was more than 50%. So you would want to play with that to get this in a better state. But that's an example. I mean, how would you know that if you didn't use machine learning techniques? You wouldn't, right? Same thing, with principal component analysis. Similar kind of thing. If you look at this, these are the predictions versus reality. And this is, the blue is the ground truth. So how well did we do? You can see here that one class SVM did a lot better, but it's not perfect, right? Because it's still predicting some things that are benign as a DDoS attack and not. And again, we know techniques to tune this to make that better. All right. All right, so back to the case study. All right, so we talked about the anomaly detection, we talked about the confusion matrix. So let's talk about the model evaluation, right? So how well does this model perform, right? We want to look at a visualization for that. And system one. But anyways, so this is how well the model works. This is all stuff that we've done already, right? Think about how we've worked through the machine learning life cycle. We know about feature importance and how to figure that out, right? We know what a ROC curve is. This is good, right? What's this line? It's guessing. So if it's below the line, it's not better than a guess. If it's above the line, it's better than a guess. But you can tune that based on your hyperparameter settings to get your ROC curve to be better. A lot of times it's either contamination or new is set wrong, right? It's either too aggressive or not aggressive enough, and that can affect false positive, false negative. Your prediction distribution, normal versus anomaly. Is that right? Is that wrong? How would you know that? You could go back here to the beginning, right, where we did the analysis, right? Here's the data set analysis. Do I have it? Maybe not. But basically what I would want to look at here is if I had a labeled data set, is what percentage do I have of true versus true positives versus false positives? And my prediction distribution should match the characteristics of my data set. And if it doesn't match the characteristics of your data set, if you have the ability to do supervised learning or an ensemble method, that's where you tune the hyperparameters to get it closer to what the actual composition of the data set is. If you ask your LLM about hyperparameter tuning for these different algorithms, you'll get a much more detailed and coherent explanation than I just gave. But it will also give you some basic guidelines to go by about what to expect as to anomaly percentage and things like that. And that is super important because remember, when we looked at it where we said, 20%, if we set our contamination to 0.2, that 20%, that magically we have 20% anomalies, that's why. So very important concept. Risk score, we came up with our risk score as part of this notebook, right? Risk as compared to what? Just compared as to what the code is in notebook. But you could do risk scoring. When I've done risk scoring in the past, we always ask the basic questions, right? Is it reachable? Is it detectable? Is it exploitable, right? Those are three kind of things that are elements of risk that are universal. I think that came out of Adam Shostak's work, which came out of SWI when I was there. But it's a tangible way to try and figure out what's more important than another. You might be able to say if it's on the edge, its reachability score is 10, and if it's down in the third tier of one of your applications, its risk score is 2, right? But you need to come up with those kinds of things, make sure that they're interpretable and explainable. And if somebody says, why 10 and 2, say, I don't know. Best guess I had, and we're using the data to try and validate that. And then, then we have some predictions here about our data set, and then the comparison of the models, right? What's the difference between isolation forest and random forest? Random forest looks like it's perfect because it's a synthetic data set. So that would be the one, even though they're both really super good. This is kind of fun. Decision tree rules. This is a sample. You can actually, if you want to see what your decision tree rules are, if you really, really, really want to look at a whole screen full of a tree, you can ask your model for that information. But this is just an example, right? And remember, anomalies are closer to the root of the tree. So it would probably be things in from the largest anomalous value to the lowest. And that would be how it would tease it out. So we talked about interpretability. Here are the segmentation rules in this example, right? The number of ports contacted, many ports is potential lateral movement scanning, right? These numbers are kind of right on. Usually you don't see the same host looking at multiple ports. Usually I'm coming in, I'm going to one port and doing my business and getting the heck out of there. Again, few ports, normal communication, right? Risk score, right? High risk is multiple suspicious indicators, right? Like ports contacted and things like that. Low risk is normal operational behavior. And then things like high CPU usage. This is a home run. It's the simplest thing ever, and it's probably the most important detection is CPU utilization. You know what the normal utilization of CPUs is, and crypto mining jacks it up. So if you want to find crypto mining, look for CPUs that are spiking. All right. And then we had the deployment simulation. We used our scoring function and our engineered flow features and all those other things. And we simulated a mining incident and based on one of those anomalous flows, and it looks like our detector caught it in the case study. And the way it did it was it gives some segmentation policy recommendations. So you could take these outputs and feed them into a script that would do something in your networking environment if it doesn't have a way to interface with it directly. But this is something that you can do now, right? You can script this kind of stuff, and you could kick off a script if it had a segmentation policy recommendation of immediate, right? You could put it in another VLAN. You could put it in jail, right? You could restrict its communication outbound, those sorts of things. Uh, and then, it compares that with a normal flow, right? So these are all things, again, this is synthetic data, but these are techniques you could use with real data, and you could get some of these indicators and take action. All right. So then what do we do? Monitoring and continuous learning, right? We want to look at our rates by hour. We want to look at our false positive rates by hour. Average response time. Look, we've got a great SLA. We have threats that are detected by hours. And this is the kind of stuff, right? These are operational dashboards that you could use to help power a solution like this. And you know, make real impact in your environment using the techniques that we've called out here. So again, this is all kind of best practices here at the end. Uh, Tells us how our health is doing. Uh, when do we want to retrain? These are all pretty good guidelines, right? Uh, Data collection, right? You got network flows labeled by security analysts, right? Of which you are one. AI can't replace me because you need me to tell you what's good and what's bad so you can train your models. That pizza box that you're buying from the AI vendor that says it can figure out everything, that doesn't know jack squat about your environment, and it still needs to train the model. It doesn't know anything about your full business cycle, right? What does your business, the shape of your business look like over a year? Do you think your pizza box knows that? No, it's not going to start spitting out useful data unless you train it and tune it. And who's going to do that? You're going to do it. So anyway, sorry, cutting my soapbox. Incident response outcomes. If you don't do postmortems on your incidents and have a standardized format for data that you can mine to use for AI to detect further incidents, you are missing the boat. Oh, I hate doing postmortems. You should like doing postmortems, right? Because that's how you get data that's useful. We use the heck out of these at Google and Microsoft, right? Postmortems are the lifeblood of using AI in your cybersecurity because guess what? You use those to do supervised learning and to validate any unsupervised or ensemble methods that you use. And without that data, how do you know how well your algorithms are doing? How do you know how well your detections are doing? For retraining, you're always going to have to collect new labeled data, right? Back to what we were talking about before, having the data collection for retraining. And somebody's going to have to retrain these models. They don't retrain themselves. Your pizza box might say it does it, but now you can say, oh, can you show me how you do retraining? And watch the systems engineer sweat or the sales guy sweat. That'll be fun because they can come in and blow the AI, smoke up somebody else's, you know what, but they can't blow it up yours because you know what's going on, right? Um, so these are all things that we can do. And again, this is kind of a call out of the objectives we achieved by doing this case study. And you should look into these some more. But again, this is real machine learning. This isn't just some plugged in presentation. It is synthetic data. You could use real data if you wanted to. I could probably go through in an hour and have this use a log file. This example here, this uses a log file. It can use many kinds of different log file, right? And but this is using one from OTRF. I have another example that I will show you in our next class that actually uses Windows log data that it pulls in natively. So it's not a CSV file, it's actually using the JSON log files, which is pretty cool. But this is the kind of stuff that you can do now, right? So this is real data. This is data that I pulled from a repository. And if you go look at my GitHub, there's a list on there for data sources. I think I put a link into it in the chat. If not, I will afterwards. But I have boatloads of data sources up there for all these logs that I'm getting in data sources. And if take what we have learned in this course, take these examples, go and apply it to some of these real data files, right? All these examples I'm showing you, some of the case studies and stuff where I use synthetic data, it's not true, but a lot of these cool things with all these dashboards and stuff, it's real actual attack data. Maybe it was generated, but it's actual data. And this next class we'll see like NLP processing of log files, looking for keywords and finding Mimikatz and fun stuff like that, right? I've got the ability to go and do all this stuff now. All right. So again, as usual, I'm way over and I'll get off my high horse now. And so that's it. So, I've kind of taken you on a journey. Hopefully this is all making sense, right? You guys know how to do all this now. That is the most important thing. I want you to understand that we have covered everything in this course, that you know how to use an LLM to do this kind of stuff to get results. You know what the machine learning lifecycle is. You can use LLMs to write the code for you and help do the analysis and create the visualizations and dashboards and all this other stuff. So now you just got to go do it. Practice on these synthetic data sets, practice on data sets of information at your company, right? Use your LLM to do other stuff, right? Besides doing machine learning, what else can you do? You can write documentation, you can do analysis, you can do reports, you can do dashboards for things that aren't related to, anomaly detection, right? Use the tools at your disposal. And you're not going to be one of the people that gets laid off because you're going to be AI ready. All right. So what do you got to do next, right? You can do some research based on some of these things. Find out what what all the vendors are doing with AI or claiming to do with AI. Now you should be able to ask questions. You won't be sitting in the lunch and learn with a vendor salesperson who's spouting all the things that their system can do. You can ask them questions and they'll have to say, oh, I'll have to get back to you. And then you can stump their systems engineer. So you know what? You're in a good spot. All right. So Q&A. Questions. We got a couple minutes. I didn't run over the end. I'm getting a little bit better. Almost left the appropriate amount for questions. Anybody got anything? I know I've had the fire hose turned on you again. If you don't, that's fine. All right. So next class is assignment 6, which will be the last assignment till we turn in the capstone. I will have some guidelines after class 12, probably between 12 and 13. And that will tell you what the deliverables will be for the capstone. And we'll go from there. So assignment 5, or I'm sorry, assignment 5's out. Assignment 6, I put in the chat too. So if you want to get a head start on it, I know that was a request. You can feel free to do that. But so that's all I got for today.
Hey, real quick, Steve.
Yeah,
Um, I apologize I wasn't able to make last class. So I'm a little bit behind. If I have any questions, do you mind if I just drop it in Discord?
nope, that's what
Over
it's
the
there
next
for.
couple days. But like I should be pretty good. But like I said, if you wouldn't mind, I might ping you a little bit.
Anybody can ping me anytime in Discord. Y'all know that I lurk on Discord during the week between classes. So I'm happy to answer any questions. Feel free to ask it either in the open chat or DM me if you want, and I will do my best to get you an answer.
Thank you so much. I really appreciate it. I'll put it in open chat because I prefer to just be like open and you know what I mean? Maybe something I'm
Yep,
thinking could help somebody else. But yeah, that's perfect. I really appreciate you, man. Thank you so much.
yep, good deal. All right, and like I said, if it's something that you don't want open chat, I'm cool doing that too. And because I can appreciate sometimes you don't want to ask a dumb question in a crowded room. Not that there is such a thing as a dumb question, but you might think it's dumb and not ask it. And I want you to ask all the questions.
Have you met me and my ADHD? Like I won't ask anything in front of anybody.
Yeah,
Sorry.
dude, ADHD is my superpower. That's all I have to say. I might be chasing squirrels every once in a while, but sometimes magic happens when you catch a squirrel.
Exactly. Or like when we get focused, like hyper focused, you know what I mean? Like I've been
Oh,
able to accomplish significant amounts of creation in short amounts of time. So I totally understand what you mean.
yeah, but that's, I mean, I have people ask me all the times, how did you figure that out? I was like, I have no effing idea, but I did it. And my favorite thing is I'll write code and then I'll go and I'll do something else and I'll come back to the code and I'm like, holy crap, who wrote this code? So I get it
I
totally as
keep
a
doing
fellow.
future ads. So
Uh,
like this, like I'll have this thought and it'll spin out and it'll be a new project. And it's like, oh, okay, well, this is how I integrate this like recursive, like what's the word? What's the word? I'm sorry.
it's but to me, I think for me, I see systems. I
Mm-hmm.
don't see components.
Mm-hmm. Mm-hmm.
And I go from systems to figuring out what the components are, not the components to the system. And I guess that's a little bit unusual for some people. But I think that's part of ADD. I mean, it's served me well over the past 40 years, but
That totally makes sense to me. I like that's 100% the way that I look at things when I'm doing, you know what I mean, like a governance risk compliance, like an assessment. I look
yep,
at people, process, and technology. I don't look at, you know what I mean, like, and then I work down.
yeah, yeah. It's like you can start with here's the sock and here's all our controls, and I'm going to go out and find them. Or you can look and say, oh, well, here's what the landscape looks like, and what do I think of how it's implemented? Right? Is there?
Exactly. Here's the actual operation of the complete system, like between what's computing, how people are supposed to, like how people actually interact with it, and how they're like supposed to interact with it. I
Yep.
totally get that. Thank you so much. I appreciate you.
Yeah, you bet. Tutu.
Hi, can you explain the concept for me of how do you implement LangChain? I know there's some like framework that can be implemented with AI and ML. So, can you explain the concept behind LangChain, Hugging Face? Um,
We'll, we
there-
will we will talk about those a little bit more in adversarial AI.
okay, because I'm
So
trying to see how that comes into play in here because I'm looking through job descriptions and I'm seeing those concepts like Hugging Face, Spark,
yep,
Chain,
yeah,
and
yeah,
different frameworks that I never even
Spark's
heard
a
of.
pipeline, but yeah, those things like Hugging Face and stuff like that, we're going to talk about that during adversarial AI because those are some techniques that we can use in like image processing and things like that. So we'll touch on those in more detail in another class. All right. Anybody else got anything? If you do ask Paulina, she has all the answers. All right. That's it. We're going to stop early for once. Unless there's other questions. If not, hit me up in Discord. Enjoy your evening, and I will see you on Thursday.
Thank you.
Thank you. Good night,
Steve, I'll get
everyone.
those-
Thank you.
Yeah, you
Steve,
bet.
I'll get that assignment I missed and the current assignment over ASAP.
Oh,
Whenever you get a chance, you know me. As long as it's in by the end, I don't care.
Steve, I do
Copy,
have a really
copy.
quick question as well.
Yeah, you bet.
I came across an email about fraud analytics, AI, ML from same company Elevator. And I was looking through their curriculum. It sounds a little bit similar to what we're doing now. Is it because it still deals with fraud detection, right? There's still some analytics and detection involved, and I think they're still using the same tools. My
Mhm.
question is, is it very similar to what we're doing
Your
already?
yes, your skills
Or should
here
I don't know
are
if I could have taken that one before taking this.
no. It is. I won't say it's identical. I don't know the content of that particular course, but I would suspect that everything that they're doing is very similar to what we're doing, because if you think about it, it's just a different data set. It's not necessarily a cybersecurity data set, but you could find anomalies in financial information using these same techniques.
Right. And it's the same people. It's the same as Elevator, right?
Yep.
And I glanced through the curriculum. They're using Jupyter as well, scikit-learn as well.
Yep.
So I figured, I don't know. I guess it's from the financial aspect, from a financial industry aspect
Yep.
for
Well,
fraud.
yeah. I would encourage you to ask your LLM to explain that. But it's basically, you hit the nail on the head, right? Is the process is the same. The machine learning pipeline is the same. The tools and techniques are the same. Just the only thing that's different is data, right? I could take the anomaly detector that we used for malware, and I could adapt that to find anomalies in financial information, like transactions and stuff like that. So this is a great point, and I'm glad you asked this question, right? You can transcend cybersecurity with these techniques. These
Right.
techniques are applicable to anything, right?
Right.
Right. So go, I know everybody's got a lot on their plate, but go through and look at some of the stuff that's in scikit-learn, right? They do climate, they do genetics, they do finance, they do everything. And it's all using the same stuff that we have been learning in this class.
Is there any other tool that's like better than Anaconda, Jupyter Notebook, or scikit-learn? Is there any other platform that is even much better than scikit-learn that we can play around with?
So
Or learn?
I would say this: what happens a lot is people experiment and do analysis using scikit, and then when they operationalize it, they might do it with they might do it in Apache, they might do it in using TensorFlow or something else, right? So the difference is where you go from it being an experiment to having to scale to enterprise size. That's where you would step out. But the algorithms are the same. They're just implemented in a different framework, right? And it's not going to be in Python. I did a thing, and it's like if you take your Python and you can translate it into something that runs in a Docker container. And I did this. I went way down a rabbit hole. It's way beyond the scope of this course. But literally, you could take these detectors that we have and you could turn them into the deployable products, but you would want to change the back end out because you would need something that performs at a higher level, right? So this implementation of algorithms in Scikit may not scale as big as it does in some of the other platforms, right? Like Apache has the same algorithms that you do in Spark ML, but Spark ML is optimized for streaming large quantities of data.
That's
So
exactly.
is Apache like another sandbox environment for hands-on learning and training?
Well, you can do all the learning and training in Scikit, but
Yeah.
this is where you go from having an experiment to operationalizing something,
Enterprise company or enterprise environment.
Exactly. But it could be the same code, but you just put it in an Apache Spark pipeline as opposed to having it run in Scikit.
That's one of the things that I'm actually working on with my project is scalability. So that, you know what I mean, I can run everything and validate, you know, my ML pipelines and everything locally.
Mhm.
With like very rigid, you know, 250 or 512 SHA and, you know, HMAC and all that stuff, but at the same time, like have that consideration where I'm kind of like more of an AWS person. So I
Yep.
can just drop it in a Lambda and it's scalable to a corporate to a corporate perspective. I just
Right.
need to make sure that those functions pass off correctly.
Yeah. And that's a good example, right? But because when I would, well, actually, I think everywhere that I've been the biggest, the majority of the stuff we did with ML for cybersecurity was done in Apache Spark ML. So we use that as a pipeline, but we did a lot of the proof of concept and validation using, guess what, Scikit, right? Because it's fairly straightforward to transfer what you are doing. Well, put it this way, you think about this, right? We trained a model and we exported it as a pickle file, as a trained model. And guess what? You can import that model into Apache Spark and use it there.
This
So
is
think,
perfect. I'm going to start looking at Apache Spark just so I can also get a secondary like perspective for
yeah,
scalability.
Spark ML is cool.
I started looking at the Apache Spark right now to see like, is it like free? Is it, do you know how much, if it's, do you pay for it monthly or, because I'm on a page now, I can't find where, but it looks
I
pretty.
believe that there is open source Apache Spark ML. I'm not sure where you have to start paying for it, probably for support, but most of the stuff is open source.
Yeah. Yeah, it looks good. Yeah.
All right.
Thank you.
You're very welcome. All right, great discussion, great questions. Thank you so much. And unless there's anything else, I'm gonna call it. And then if you think anything else, Discord is your friend or send me an email.
Oh,
Thanks, everybody.